Hey guys, it's Vince. Today in this video, we're going to be discussing CNC plasma robotics. We have a content creator here who was nice enough to design a CNC plasma robot on an ultra low budget for his audience. Let's see how he's done.
But right now, let's talk about how I built it. So the gantry is actually a repurposed laser engraving machine. This was given to me by a website called Banggood. Now I rate Banggood because I actually bought quite a lot of stuff from them, including
the content creator purchased a laser cutter that he decided to convert into a CNC plasma cutting robot. In order to do that, you'd have to understand what you're working with in the sense of the ability to ground this chassis. We already know, like he knows, that plasma cutter does not require a very robust chassis because, again, it's not put under the loads that a Miller router is as far as rigidity, and therefore that Z-axis just moves around the chassis and there is no load on it, so it's just performing the cutting, and everybody in theory should be happy. Unfortunately, if we don't know that this chassis is anodized and understand the principle of anodizing and understand that you can't ground the chassis because anodized coatings are insulated, then you're going to run into problems. The other issue is, and this what a lot of guys don't understand, is that when their gantry or any component in the transmission is plastic running on a metal frame, that plastic becomes an insulator as well, that you cannot ground the initial components of that frame. So looking at this, you can see he's already got some hurdles that he has to overcome. This is where knowledge of this field will define itself. And I say this in all my videos. There is no hiding behind your knowledge. What you portray in your video is showing the audience, do you understand what you're talking about? Or is this just a way for you to convey, hey, I have some links, I want you to buy components because I make money from them?
in the camera that you've seen all of my latest videos with, that all came from the website Banggood. Now Banggood have offered some discounts you would not believe, up to 70, 80, 90% off in some cases. This machine was called the Auto Laser Master 2. It has a cuttable bed size of 400mm by 440mm, and when I chose this machine it was rated on their website for only £150, and you can even get one similar to this that are even cheaper.
Well, the content creator wastes no time and discloses to the audience that he purchased this from a Chinese website. And of course, the price is critical because, again, if we make the price really low, it's going to really draw the audience's attention because everyone who's involved in CNC or wants to get involved in CNC realizes that a CNC plasma cutting robot is very expensive. Much more so than the 150 British pounds, which breaks down to about 200 bucks that this content creator paid for his chassis. Let's see where this goes.
You buy from Amazon, however, and you're going to at least 300, sometimes even 600 pounds for a similar machine. Now, the thing is you can actually buy all the extrusions, all the little parts. We'll have a closer look at those. You could build this with, is bits and put them together yourselves. It's actually not that difficult. But for me, literally, this took me less than a day to put together.
So the content creator has broken down it's more money to purchase this frame on Amazon. He's once again done the pricing research. Banggood offers a better price, projects that to his audience, once again catching their attention, very cheap. I can get it cheap. You've already done the research. I'll check that out. Then he goes one step further, sweetens the deal by explaining you could source the parts elsewhere, but you know what? Naturally, Banggood's got them at such a good price. Logically, most of the audience is saying, well, why would I do all that? It's too much work. I'll just go on Banggood. I trust you. And then I'll see if I can assemble it. Once again, he goes into that and says, hey, I actually assembled this in less than a day. Once again, making it sound even better to the audience who has no experience potentially with these type of CNC robots. And once they assemble the frame, he makes it sound as if the robot's done. That's what so many novices believe in this genre. The mechanical frame, guys, on any CNC production robot is basically step one. It means one part of the system is done. It doesn't mean you have a stable robot. He hasn't defined anything other than he can assemble an erector set. That's it. And unfortunately, when these DIY guys make things sound extremely simple that are complex, and you must understand all of the intricacies of details of assembly for a production robot, that's where their audience gets burned. Let's see if I'm wrong or I'm right. Let's see where this goes.
And it's got all the movements, it's all calibrated and works brilliantly. Right, so when we're talking about the £150, I do mean just the gantry, which is the most important part, including all the software and everything like that. So you will need your own plasma and compressor to go with it. Now this one is CNC compatible and only cost me £235. There will be a link in the description. This goes up to 50 amps and will cut 20mm thick steel. I've tested it. So it's very important to know you can't just use any plasma machine. You need to use a non-high frequency pilot arc. And the reason is that your torch is never going to be touching the steel. It needs to create an arc that will bridge that gap. But it also can't have high frequencies because you'll destroy your controllers.
The content creator now discloses to the audience that the CNC chassis is what drove the title of the video to the cost that he put in the title of the video. He never included the plasma system, which is required to turn the chassis into a functional CNC plasma production robot. So looking at that, we already know why would you not include that logically, because without it, you essentially have a chassis that's a paperweight because it's not doing anything. The next thing he discusses is the plasma cutter he selected. He discusses with his audience to select a low frequency start unit that is using a pilot arc, and if you don't use this, then you can get EMI, in which case it could destroy sensitive electronics. Well, the fact is most electronics will not be destroyed at that level. Typically what you'll get is instability. The other factor is that out of his own mouth, he states that this unit can pull up to 50 amps. Any person out there who does any source of research at all on electromagnetic interference will find out it is present on all electronics. Anything pulling any electricity generates EMI. The question is the amount of EMI generated from those electronics enough to cause instability or, in severe cases, potential damage? 50 amps, for those of you that don't know, is massive. Okay? When we're talking about a cutting tool of this capacity, pulling 50 amps, regardless if it's pilot arc, whatever terminology we want to use, you are still pulling a massive amount of electricity. That means that building a robot that's going to deal with very low voltage signals to control the motors of it needs to be built accordingly to diffuse that EMI. So once again, we don't have penetration into them sensitive control signals that would mitigate the robot from being actually productive. So think about what I'm telling you. Now, to be more concise, because I know there's guys out there that want to see even more evidence, no problem. We'll put on screen here about a high frequency start plasma cutter, which many of guys have heard of in the past that generate lots of high frequency noise. Those are the ones that seem to get the most attention when it comes to CNC robotics because most guys associate them with how their robots become unstable. Then there's a blowback start type plasma cutter, which once again is supposed to give more stable results because it's a moving start unit where a movable spring-loaded electrode and a DC spark start the plasma stream. The other thing to keep in mind, guys, is while he discussed that his unit is using a pilot arc, you can see here on the screen, a common assumption is that if a plasma cutter has a pilot arc, then it's a low frequency. This is not the case. Low and high frequency plasma cutters can have pilot arcs. So once again, we have a lot of details that need to be covered, including the plasma cutters that he selected. You can see on the screen here, I've got the plasma cutter that he's using, and I'm going to scroll down to the description. And it does say CNC compatible. It does say pilot arc non-touch, but that is really all it states. CNC compatible can mean a lot of things, guys. All plasma cutters are actually CNC compatible. I mean, realistically, the controller doesn't know what plasma cutter you've selected. The bottom line is what knowledge has been put into the controller to assure that proper grounding is done And that means using the proper double shielded cables and also implementing use of the proper controller to send and receive your signals, because once again, they are the most critical for providing a stable production robot. The misconception that you using a low frequency plasma system is somehow going to eliminate all of your EMI problems without proper grounding, without using proper double shielded cables, and without implementing the proper controller, meaning staying away from universal serial bus, because again, it's completely unstable for this or any CNC application. You are asking for trouble.
However, even in non-high frequency machines, there is still a little bit of high frequency, so you'll want to protect it.
All right, now he says that there is still present some high frequency EMI in the low frequency plasma cutter. If you are using a plasma cutter for your cutting tool on your CNC robot, you must pay very close attention to proper grounding, double shielded cables, and what controller you're using for signal manipulation. Think about the redundancy in what I've just said, because I've said it now 3 times. This is getting convoluted very quickly, and this is where end users get really confused. And what's really interesting, you'll notice, is he hasn't discussed the compressor use. Compressor is another large piece of industrial equipment that pulls a large amount of amps. It also is going to make EMI, and not only is it going to make EMI, it's not a filtered unit. It's not anything special in terms of it being designed for CNC use. So taking all of that in and understanding the principles of what you're working with is really what delegates the effect you're going to get with your robot.
So after much experimentation, I put this plastic pipe on mine to act as a bracket for the controller, which is this part here. That gives it a good distance away from the machine where there's potential high frequencies, and being plastic, it's insulated away from electrical current.
We have a piece of plastic pipe similar to conduit mounted in a U formation attached to his plasma table, and he's illustrating with his hand position, that's probably 18 to 20 inches, that space is enough to mitigate the EMI generated by a 50 amp plasma cutter. Guys, fact of the matter is, for a Plasma CNC robot system, to mitigate EMI by distance would be no less than 10 to 15 feet, to be a significant reduction to where, once again, we're not going to possibly corrupt sensitive signals that are in the 5-volt range. Now, why do I say 5-volt range? Well, we could see right here in his illustration an OR-TOR type motion controller. I'll put it on the screen here so you can see it works off of USB. And you guys all should know from my previous videos, unless you've just joined and check them out, that universal serial bus has no place with CNC robotics due to its unstable signal transmission. And what do I mean by that? It works on a 5-volt format, and being so, it is unstable with not only EMI, but also grounding fluctuations and voltage spikes. This is fact. I actually go into a general discussion about random disconnect issues that are happening with the UC100 USB motion controller from Balzis, lead engineer over at CNC Drive. This unit is one of the most premier USB motion controls by one of the most reputable manufacturers in Europe. Now, what's interesting is, if this is one of the most reputable manufacturers in Europe, think of the Chinese developers who are manufacturing these USB motion controllers. If his is susceptible to this, meaning CNC Drive's UC100, then we know these are also susceptible to it. And I will put that on screen as well, because the more evidence I provide you guys, it at least makes you all hopefully do your own research, and the more due diligence you do, you will confirm exactly what I'm telling you. When you are working with a CNC plasma system, the only way you would want to have any type of signal transmission outside of a parallel port, which once again should still be using a double shielded cable, would be using an Ethernet controller, because again, its signal stability is much, much more effective than what we see with USB. And when we see things like this being done, and then he also explains that this conduit or plastic pipe is mitigating electric currents. I'm not exactly certain what he means by that, because unless he's running wires inside of that, that would be an insulator inside of plastic. However, I highly doubt that there is any EMI shielding inside of that. There are plastic pipes that do have it. He did not state he's using that. You can rest assured, anything exposed, and we see the controller exposed right there, it is getting hit with electromagnetic interference. The question is it stable? We don't know. Is it best practice? Absolutely not. And should you invest in doing that? I do not recommend that, because the fact of the matter is you never know when that EMI ghost will hit the machine. And that's what these guys, again, don't understand. A content creator shows a video and all he wants to do is make sure that his audience is ready to click on the affiliate links he produces.
So if we look at the torch bracket that I've made here, one feature linking to what I've just spoken about is this ground wire. Now this goes all the way back to the machine's ground, and what happens is as the high frequencies travel through the torch, they actually gather on this plate and are instantly ground back to the machine, protecting the rest of the gantry. And since doing that, I've had zero problems.
The content creator is now explaining his grounding process, and he states very clearly, and I hope all of you in the audience understand what he said when he explained, since doing this grounding, I've had zero problems. That would insinuate that prior to doing this, you've had problems. The question is, are all your problems eliminated? Is this chassis properly grounded in best practice? And it's not. He will not tell you he doesn't know what best practice is. He is letting you think that naturally you using a banana plug and some unknown gauge lead going back to his machine is now a grounded chassis. That's not correct. I'm going to put on screen a direct excerpt from Lincoln Electric's PDF on grounding and EMI mitigation from actual engineers in one of the largest factories that produce commercial grade plasma systems. Let me ask him and everyone else this. If this is best practice, and this is one of the largest commercial manufacturers of plasma CNC systems, shouldn't we implement what they're teaching? Not only that, if it's a free PDF to download on their website just by doing a Google search, why didn't he present this to his audience if he was so adamant about showing them how to do a plasma system? That's the real question. I do not understand how anyone could get upset when I produce facts that I'm not stating, I'm showing you. I'm essentially a messenger showing you what fact is. And yet I show this guy, I show other people this, and the ones that thank me are the ones that are serious. The ones that don't thank me are the ones that usually follow these practices. And when we see this, it hurts the entire community, because these are the people that go out and spread misinformation. This gentleman has a large audience, well over 100,000 subs. And to be producing content like this, when he really doesn't know what he's talking about, validated here, not by me saying it, by me showing it, it just defines that all this is a quick money grab for affiliate links selling components he really doesn't understand. You guys will be the judge, but hopefully this video will save you thousands of dollars and countless hours of time.
Secondly, I'll detach this wire. This wire used to connect to the laser, and now it operates the relay.
Guys, I've said this before and I'll say it again, and you'll see it in all of my videos virtually. Double shielded cable is essential on any CNC robot, let alone a plasma robot, which once again is the worst at producing electromagnetic interference issues. Make sure you use the proper double shielded cable. Once again, I'm the messenger. I will show you right here excerpts from Lincoln Electric explaining shielding, and I will put up on screen so you all can see, once again, defining double shielded cable is the most effective because, once again, it uses a mylar foil and a tin braided copper shield, not one but two, producing that Faraday cage effect over our leads to protect from EMI and diffuse it properly when the shield drain is grounded to the ground bus of the system.
Switch. Right, so I've elevated my cables up, and that keeps everything moving correctly just by using a piece of wire and some magnets. I've got a metal roof, so I can do that, and that just simply comes down. Now, I will create something a bit more better than this. This is just a bit Heath Robinson, but it works brilliantly. and I will consider this for getting all of my cables off the ground if needed.
Using magnets to attach your cables to your roof to get them out of the way of the plasma table is terrifying. At any point in time, that gantry can make contact with those leads, pulling them down, or for that matter, there might just be a hiccup, maybe through vibration the magnets move a little bit. Guys, I'm telling you right now, in his own words, he's admitting it's like a Heath Robinson thing. I guess it's like jerry-rigging. You guys need to be very careful on what you're following. He shouldn't have even put this in the video. Had he identified that this is an inferior way of, once again, getting his cabling out of the way, best practice would have been, as a responsible content creator, to put that in the video so other guys not only learn from it, but also understand that this is terrifying for those following these videos to implement. And believe you me, there will be a guy out there who will do this. And again, I can't emphasize this enough because content creators never discuss in their videos. If you have homeowners insurance, if you have shop insurance for whatever assets you have, and you use something like this, you better hope to Jesus that that thing never falls. Because if it makes contact with that plasma torch, you guys could be in a world of hurt. And that's just putting it mildly. So again, watch cautiously, understand what you're looking at. And if it's being identified as any content creator does and says, hey, this isn't really a smart thing to do, don't do it. Once again, I know many of you are saying like I am, why would you even put it in the video? Once again, do they have your best interest in mind? You have to ask yourself.
Talk about this. This is GRBL Controller, and this is an app that you can download from the Play Store. It's free, or you can get the paid version and you get a few more range of options. Now, I'm not sponsored by these guys, but it is probably one of the best ones that are out there as far as CNC control goes. And you can not just operate a laser, but you can operate a mill and all kinds of other things. In fact, my other CNC machine that I've got for engraving and things, I also control it off this device also. So this is the main screen. So you've got data on where the X and Y axes are. So X is going that way, Y is coming this way, Z is going up and down. But we ignore that one because we haven't got a Z. So you can see in the background that I can move the CNC machine however I like, just using the controller. This button here with a house on it, that's home. So I can click that once before homing cycle, yes. And then what there are is there are limit switches on the CNC machine, and that will take it back to the furthest corner that it can reach. So these buttons here are up and down for the Z.
We can see here he's using a Gerbil motion control software, which once again validates that we're using USB. A question that comes up a lot with my potential clients and regular clients is, what motion control software do you recommend? And I always say the same thing. If you're a novice, then I highly recommend staying with Mach 3. Then the main reason that is because Mach 3 is the most mature motion control software on the market. The biggest flaw that most guys will bring up is the UI. It's not as pretty as some of the newer motion control software. And that may be. The issue is easily resolved by you downloading a new screen set, which is usually free, and that will change the whole look of the software. The beauty of this software is that if you look up any term dealing with Mach 3, you can find a lot of information on it because most end users have already encountered the problem that you are. If you're looking at ultra budget, UC CNC from CNC Drive is excellent motion control software. Do I recommend these type of apps as far as motion control software? I do not. And the main reason I don't is because, once again, the amount of budget that you put into the software delegates usually how many features that software has. Now, we can get into a piston match and say, well, I just need this. If the motion control software you're using works for your application and you're happy with it, then God bless you. I'm talking about the majority of end users out there that want to do it right the first time and not rebuild a machine 4 times over because they figure out that, hey, you know what? This would be so much better if I just had this feature. These are questions, once again, that come up all the time. And once again, until you're an end user and you're actually fabricating with your machine, you really don't know what you need and what you don't. Most of the time, the software limitations are what you're going to find the fastest. So think about what I just said before making your investment.
Looking into CNC plasmas, I did actually check with one of the UK's leading manufacturers, and the one I wanted came to a whopping 20 grand. Now, if you think that's expensive, friends of mine who had already bought one, they paid 40 grand for theirs, and it's still not working right. Now, I propose this question. If you're paying that much money, are you going to get that much more performance? And I would argue that you're not. The cut will only be as good as the plasma torch itself. And so if you've got a really good quality make of plasma, that is as good as the cut is ever going to be. Everything else to create the movement and the software, there's not a lot in that really.
Well, we certainly have a lot to unpack here with what this content creator is explaining. Let's start from the beginning. First and foremost, he tells us that the initial table he was actually looking at from a reputable UK vendor of CNC plasma systems was 20K. We know that's a lot of money. He made that very clear. He also made very clear that his friend purchased one that was 40K and he's still having problems with it. Well, guys, let's just break that down real quick. The reason these chassis, and when I say chassis, I'm talking about the CNC production robot of a plasma system genre, are so expensive is the amount of engineering and manpower it takes to build a stable platform. Now, whether or not he understands that, that's fine. A lot of guys don't understand that. These guys are paying real engineers to go in and make sure that they sell a consistent system. And when I say that, I'm not talking about these fly-by-night companies that keep popping up all over the internet selling tables for 25% of what their retail value would be from a pro vendor like I'm assuming he's talking about. There is a lot of engineering that goes into these units, and once again it's required so that when an end user like himself or his friend buy one, it should work out of the box if it's inclusive of all electronics and of course the mechatronics to make the table once again function. This is fact. Now, what he specified with his friend, we're missing a lot of information here. He's saying his friend is experiencing problems. His friend should have went right back to his vendor who sold him this $40,000 contraption and said, hey, you know what? I'm having problems. If I'm having problems, they should be willing to stand by and make sure that that table is functioning as it should. If he's not getting anywhere with them and they just want to play games, then at that point he should be contacting his charge company or debitor, whoever issued the charge, to once again take action against them to make sure that they're held accountable for the purchase he's made. Now, I don't sound like a regular vendor in this genre because most vendors say, ooh, that's a scary tactic. No, it's a fact tactic. I want you guys to be protected. And why do I say that? Because I really have nothing to hide in that I'm expecting when you purchase something from me to you to come back and require support. That's part of this genre. This is an engineering field. You're going to have questions. You're going to require possibly updating the system down the road, or you're going to want to maybe look at different variables that you can do to attain a different level of success for every robot you work with. I expect that. This, what he's explaining, really goes down a rabbit hole because, again, we're hearing kind of vague information. He's having problems, meaning his friend, and it stops there. Either way, you know how to handle that type of situation. Now let's get into what he specified about, well, the plasma cutter is what dictates the quality of cut of your entire system. This is partly true. And when I say that, naturally, just like every other portion of CNC, and whether it be a mill, a router, a plasma cutter, the more you invest in the cutting tool, in this particular instance, it's the plasma cutter, and there are different variables when it comes to selecting one, it does naturally affect the quality of cut you'll get. If you invest in a high definition type plasma cutter, you're going to pay thousands of dollars. But look at the tool you're investing in. Makes sense. If you look at buying an ultra budget plasma cutter like he did from overseas vendor, then again, look at what you're actually investing in. It's all logical and it's all breaks down to that old saying, you get what you pay for. There is a definitive difference by buying a quality unit versus a budget unit. I don't care who produces it. It's a fact. The other thing to keep in mind is that Whenever a content creator, or anyone for that matter, says that that's the only variable of the quality of cuts and the automation, electronics, and the motion control software are really virtually all the same and don't really matter, I'm telling you right now, guys, there is a miss. We heard him specifically say that the cutter is the most important thing, and what he's failing to realize, and I'm going to put more evidence on the screen through a Google search showing you all the issues with USB disconnecting, which is exactly what he's using, and it shows definitively, number one, as I've said earlier, he doesn't know what he's talking about, and number two, how anyone can think the neurological system of the robot, which is the automation system of the robot, along with all its electronics, is just all the same and it really doesn't matter? That's absolutely crazy. I have never heard such ridiculousness on my channel from any content creator, and that's a fact. I doubt many of you would agree with what he said. And I'm telling you right now, for those of you who have experienced problems with the neurological system of your robot, which once again would be the automation system, you will attest to the fact that it sucks. You go around chasing your tail. I've had many guys spend hours, thousands of dollars to try to rectify what's right. I work with a lot of businesses and they don't have time to rebuild and guess. They don't want to guess. They want to purchase something that makes sense by a reputable vendor who's there when they need them.
But still, if there's a manufacturer out there who wishes to challenge that, I'd be very happy to have a look at their machines.
I truly have to say that he is a stand-up content creator for offering to take any manufacturer's CNC plasma system that they will offer him in a $20,000 to $40,000 range so he can review it and give his opinion of it. I'm sorry, sir. I have to ask a logical question. We just saw you convert a $200 or $300 laser cutter into a hybrid plasma system, which cut for maybe a couple minutes on camera. You're using a USB motion controller. You briefly went over at surface level EMI mitigation to the point of you explaining that your plasma cutter states CNC compatible. Yet when we went on the manufacturer's listing overseas, it never states anything about robotics use other than saying on its actual case, CNC compatible. We never heard anything about double shielded cable. We never heard about a star point grounding system or proper grounding at all, really, other than you using a banana plug on some unknown gauge lead going back to your machine. Realistically, we have to look at what we're hearing from. And in this point, we know that this gentleman really doesn't have the knowledge to discuss anything in this field other than the fact he's able to run the machine to get a cut. And that's a big difference than giving an overall review on anybody's system, or for that matter, even covering the amount of detail required to judge a $20,000 or $40,000 system. Because one of the main points that he overlooked and never discussed with us, the audience, is the fact that a $20,000 robot in terms of a CNC plasma system disparity from a $40,000 robot usually is going to be the size of the machine. He never covered that because, again, that's the biggest disparity when we start looking at CNC chassis, because steel costs money to make those chassis. Then, of course, the larger the chassis is, we need larger motors to accommodate that larger chassis. These are facts. So once again, I'm not understanding the level of detail you're willing to offer anyone to give them a review. Sounds like what you're really trying to do is invest in your shop because you realize once you get that to review, they're going to let you keep it. And that's the truth. And just say that. I think more of your audience would respect the fact of you just being transparent and stating what we already know.
So do check out my links in Banggood. I do get a little bit of a commission if any of those sell, but they are honestly really good prices there.
In the end, it all boils down to getting those affiliate links in front of his audience because, again, 220,000 subs, that's a lot of people. And even at a small commission speaks about, that's going to convert much higher as more and more views come in. The thing to keep in mind is this. If you're looking at purchasing any of the components that any of these content creators offer, you have to ask yourself, what support am I going to get? If you buy what this gentleman just displayed on his machine, Are you going to get any support from him directly? Because I think we all know the answer is no. That's why, once again, using affiliate links when it comes to CNC components becomes really sketchy, because of course the content creator who's providing these affiliate links must understand the ramifications of using incorrect components that would produce an unstable production robot, because he himself doesn't know how to produce a consistent, stable production robot. This means the sale then essentially becomes more of a fraud, mainly because the content creator doesn't understand the components himself enough to even use them in his own video, let alone for him to actually help you if you have a question. So that means you have to go back to the Banggood Chinese manufacturer and hope that, number one, they speak good English, number two, that they understand the components they're manufacturing, because most of the Chinese factories, most of you all should know, if you don't believe me, look it up on YouTube and watch a video on it, they're very, very small. They're not the traditional U.S. factories that you deal with in the States. So understanding this, which I'm sure he does, it really has to draw that question of, where do we say enough is enough? You can't sell something you don't understand yourself, sir. And you're certainly not going to offer the support required to guarantee success to your audience. There is something wrong with that, at least in my eyes, because I deal with the repercussions from the people you leave behind. But I'm going to say this. If you're going to do sales, you should have some sort of integrity when you do them. And if you're not honest with yourself in that, yeah, I'm going to sell a product, but I really have no way of knowing if you'll get consistent, reliable results as you would expect, then pick a different product. Why does it have to be a product that's so complex? Because you realize that the field has a lot of interest. That's all it's about. And then it does translate into not caring about your audience, but just wanting to make money on them. Think about what I just said, because all these people out here are smart enough to realize where this all boils down to. And when you say you're getting a small percentage, we all know if we do the math, we can break down what that small percentage is. And I'll do it for everyone just to give everybody an idea. And again, I'll keep it on the low side because, again, that combined with what you make on YouTube, you're making pretty good money. Certainly enough to make a payment if you know how to budget yourself on a $20,000 or $40,000 system if it's financed properly.